Alright, welcome again to what I hope are good choices. Mic check 1, 2. Still a little quiet. Not that bad. Let me actually, sorry if this is annoying here. Okay, maybe that, yeah, that works a lot better. Now let my, okay. So it's a rainy day today, so I'm going to work on the Automate Your Network series. Rainy day is probably a good day for that. So let's go to my channel. And then to the last video I did. So the last video I did was part 1 of chapter 5, and it included the like the introductory part of part 2. So we're still working through chapter 5. So let's bring up the book. Okay, so here I am. Now where we left off is we've got some tasks to do in TFS, which is the Azure DevOps server, which I was able to get up and running. But the problem is this book is out of date, and the way it's walking, so like for example, go to TFS. Well, TFS doesn't exist anymore. Create a new work item. Okay, we're able to do that, and then name it that. Well, we can't name, you know, a work item. We already have to choose whether it's an epic or a task. So like it doesn't give us instructions for that. So, and sorry, you might have noticed in my last video I'm like really like out of breath and like struggling to talk. It's just what it's like sometimes. That's why I've talked about it in other videos. I think just making YouTube videos like this, getting used to reading out loud, talking out loud is like a valuable skill, because there's times in your life where it's just like just talking out loud, it like wins you as if you ran up a flight of stairs. So you have to be able to handle that and just maybe speak a little bit slower, take deeper breaths, and just keep going. All right, so here's the link. Alright, so yeah, and we can see I did create some work items. So if we go to boards, this is typically how I like to look at things, is on a Kanban board. I'm used to using that. So we've got the epic here that I'm doing, and then we've got a child ticket here, and that's what I followed along onto the book with. I couldn't do it exactly the same, so I did it this way. All right, so let's continue on with the book. So, okay, so we can't move it to active. So we moved it to doing instead, which is similar. So now what we need to do is clone the repository locally into the development workstation with VS Code installed. So git clone repository link. Now this is another one where we can't. So here we go. So yeah, so we need to create a repository here. So yep, automate your network from there. So we're gonna call it automate you without an R. Hands on. There aren't any branches. So there we go. I think that's good. Okay, I can't click OK. Looks like I have to build out this repository first before I do anything else. So let's try doing that. If we'll click on repos here. There we go. So now we've got the repository here. It'll be a different repository. And this is the repository that belongs in my lab. So let's go to the lab. Okay, it's the Automate Your Network lab. And we're going to do all sorts of crazy fun things that I've been wanting to do for years, but just never got around to because ChatGPT didn't exist. This book I didn't have access to. So it's like, this has been my dream to like do something like this for years and years, but it was just like way too much work. And it's still going to be an insane amount of work, but like, I feel like I'm ready for it. Mic check, looks good. Okay, so this is where we want to pull down the repository here. So we need to add some code to it. Oh, this is interesting. So we can create a we can initialize a README. Yeah, so let's do that. Let's initialize the main branch with a get ignore. Okay, so now we have the main branch initialized. So we should be able to go back to the board now, hopefully. And then click on the epic that we're doing. Click on the child. And now we can add a link to the repo, hopefully. Yeah, now that we've got the main branch. So link type, we can have build, branch, all different kinds of things. Let's just leave it at the default of build. Oh, sorry. Let's leave it at the. Let's move it to branch. There we go, main branch, and click OK. There we go, and now we have some development linked to this ticket. So save and close, and that looks good to me. So I wish I could see the tasks in here, because I want to move the tasks from doing to done, not this. So let's try adding an item. This does not work the way I want it to work. Because what I'd like to do is just, oh, here we go. So we can move it down to issues. Oh, okay. You know what? You have to have it be the epics here. So this kind of doesn't make a lot of intuitive sense to me, because I would think you wouldn't have that many epics. So like, you know, epics are like, let's ask the AI. So when it comes to an Azure DevOps server and a Kanban board and placing epics on the Kanban board, how much time would you estimate is the average time it would take to complete a full epic?
The amount of time it will take to complete a full epic on a Kanban board within an Azure DevOps server can vary significantly depending on a wide range of factors, including the complexity of the epic, the resources available, the skill and experience of the team, and more. However, I can provide you with a strategy to estimate the time required for an epic. Break down the epic into smaller tasks or user stories. An epic is generally a large, substantial body of work that can be broken down into smaller tasks or user stories. Start by breaking the epic down into smaller, manageable pieces. Estimation techniques. Once you have a list of tasks or user stories, use an estimate.
Okay. Give me some more examples of what the difference is between an epic and a project. When would you close out a project? And tell me specifically when the difference would be where you would close out an epic but leave the project open. Give me some simple to understand examples in the real world that I can use to intuitively understand the difference for this, and tell me how in the Azure DevOps server I would choose whether or not to create a task, an epic, or a new project entirely.
Certainly. Exclamation mark. Understanding the difference between project, an epic, and task can be critical in agile project management and when using tools like Azure DevOps Server. Here we'll break down these differences and give you some real-world examples to help illustrate when you close out an epic versus when you close out a project. Project, epic, and task-defined project definition. A unique endeavor with a defined start and endpoint, undertaken to deliver specific goals with specific constraints. Azure DevOps. Represented as a unique workspace containing all the repos, pipelines, boards, and artifacts related to that endeavor. Epic definition. A sizable body of work that can be broken down into a number of smaller tasks or stories. It is a thematic grouping of work that frames a large initiative in terms of smaller parts that provide business value. Azure DevOps. Represented within a project board, it can span several sprints or release cycles but is smaller than the project itself. Task definition. A small unit of work that needs to be accomplished as part of achieving larger goals, often representing a single actionable step. Azure DevOps. Represented as work items under user stories or features which in turn fall under an epic in the project's board. Real-world examples. Project example. Developing a new e-commerce website. Closure. You would close out the project once the website is fully developed, tested, and launched, and all initial objectives outlined in the project scope have been met. Epic example. Implementing a secure payment gateway in the e-commerce website. Closure. You would close out the epic once the payment gateway is fully integrated and all related user stories or tasks, like developing payment interface, integrating with various payment vendors, etc., are complete. The project remains open because there are other epics to work on, such as building the user interface, setting up the product database, etc. Task example. Developing a function to encrypt the payment data. Closure. You would close the task when a specific function is developed and tested, but the epic implementing a secure payment gateway remains open because there are other tasks to complete. Deciding when to create a task, epic, or new project, new task when to create, when there is a small, clearly defined unit of work to be completed. Azure DevOps. You add a new task under a user story or feature in your board within the relevant project. New epic when to create. When there's a substantial body of work that encompasses several related tasks or stories. Azure DevOps. You create a new epic in your project board when you identify a large thematic group of work within the project scope. New project when to create. When you're embarking on a unique endeavor that has a distinct goal separate from existing projects. Azure DevOps. You would create a new project when starting a fundamentally new initiative that will have its own.
Okay, so now we're talking about user stories, which is kind of even more confusing here. So we do know this is a project. We can create a new project. So we create new work items here, but we can go back to my here, and yeah, see, now we've even got new projects here. So this one, if we do a oh, I see. So actually, never mind. This is a, what is this? They have the same icons in the bottom, but let's try to see what this actually is. So we go to overview. Okay, so this is a project. So what is this here? I think this is also a project. I don't know why I have two of them. Maybe I was just trying to demo something. But I think I'm going to get rid of this one. I just feel like this one doesn't matter. Yeah, let me delete this project. There's nothing in it anyways. If I made a mistake in deleting it, just create it again. Okay, so we're gonna delete the project. And we have to enter the project name. Alright, now we can delete it. Refresh this. There we go. Now we just got this one project, which I think is totally fine. It's the same name as what I've got up on my GitHub. I have a fork of what he's got there. But I could say I can leave a note here. Let me update the README. I'm gonna do that. I'm gonna say like pre-fork. I'm gonna say like post-fork. Say like push. I'll say please enjoy as well. Okay, so I'm gonna say post fork. So the hands-on practice for this YouTube series will occur using the TFS style, using the TFS equivalent tools at this link. This say this fork of John's repo is only for storage of the book and of the example and of the finished example of the hands-on exercises. This fork of John's repo is only for storage of the book, notes, and finished examples of the hands-on exercises. The hands-on practice for this YouTube series will occur using the TFS equivalent tools at this link. The YouTube series is here. All right, that looks good to me. Yeah, please enjoy. I'll do a space there. That might look a little cleaner. He's got an extra one down there. So here we go. This is the post fork. This fork of John's repo is only for storage of the book, notes, and finished examples of the hands-on exercises. Hands-on practice for this YouTube series will occur using the TFS tools at this link. The YouTube series is here. Please enjoy. There we go. That looks good. So let's commit that. So we're going to commit. I'm going to say updating readme to show where hands-on work will occur. Updating readme with personal writing. Cancel. Let's stage it. There you go. Now commit it and then sync changes. All right, looks good to me. Now the thing is, this is yeah, so this is not part of the main branch. We could put it in the main branch. It's probably let's do a merge to the main branch. So yeah, so we can click compare and create a pull request. So this is like if you are working on the job, you would create this. So you click create, and now you'd pass this link to all your teammates. They would go through. They'd say, oh, okay, you've got a branch open here, and you want to merge your work in this branch, which is 11 commits, into the main branch, and then the name of the branch you are working through is here. So what you'd want to do is go through the. You could say something like, these are the comments. So yeah, you could say something like 9:14 4:43. I mean, it's already timestamped. Say reviewing merge. Yeah, and then comment on that, so like they know that you're working on it, and then go through the comments. So it looks like the first commit occurred in August 22nd, which is quite a long ways away. Like, see, we just added some comments. So you can see like why it's important not to let these add up, because when it comes to like reviewing them, like you're creating so much work for someone if you don't give like really small updates. So you can see just how much of a nightmare you're creating for someone if you uh, wait too long to merge things in. I haven't created a PR since about since the 22nd. So that was let's see here, 1, 2, 3. That was like 4 weeks ago, like a month ago. So look at all this that I have to review. That's really that's just too much. You want to be doing this a lot more often. All right, so anyways, it looks good to me. So let's go back to the issues, or sorry, let's go back to the pull requests here, and let's click on this one, and then we can say reviewing merge looks good. So yeah, so I'm not sure if I have right access. I mean, of course I do, but I'm not sure where I actually go, and only those with right access. Well, I mean, I have right access, right? Apparently I don't. Do I not have right access? That seems very odd. Okay, so I guess we can close it with the comment now. Oh, no, that was bad. I did not want to do that. How do I undo it? See, I thought close meant to accept the changes. Like I wanted to close it by merging them all in. Oh, here we go. We can go to my repositories, I think, and then how do I oh, settings up here. That's probably it. There we go. Settings, and then maybe collaborators or permissions. Okay. Security, something like that. Actions, rules. Branches. Nope. Moderation. Interaction limits. Code review limits. Limit to users. General. Oh, here we go. So all right, so I think this is probably it. Yeah, I don't know. All I know is that I have to fix that error. So we still have the branch. If I do get branch, we didn't affect anything here. If I do like a get pull, that could be a problem. But let's do a get merge. Arms book read through to main. Oh, I gotta spell it right. Okay. Oh man. I guess I'll do a get pull. Um Okay. Okay, so now we can create a new one. The other one was canceled. So like here's the one before. We can see with this red symbol, it was closed. So let's open a new one. So we're gonna say new merge request. Then we're gonna create this new pull request. Alright, and then this branch has no conflicts with the base branch. Only those with right access can do that. Do I not have right access? How do I merge it in? You know what? Let's ask the Oh, this is really nice. You can see all the files that were changed and all that right there. Oh, you know what? This is probably it. So, review changes. There we go. Finish my review. So approved. We're gonna do it to approve. Submit review. There we go. Now we can see that it's approved. But I don't see how I can. Let me try this. I'm gonna highlight everything, go to ChatGPT, and say, how do I initiate the merge?
To initiate the merge of a pull request on GitHub, you must have right access to the repository where the pull request is being made. From your description, it appears that you don't have the necessary permissions to merge the pull request. Here are the steps a person with the necessary permissions would take to merge a pull request. Review the pull request. Before merging, thoroughly review the pull request. Look at the Files Change tab to see all the changes and make sure.
Alright, so I need write permission. So maybe when I created the pull request. Wait, somebody. Oh, is this a because it was forked? Yeah, because it was forked. Okay, so I get all the issues from the fork. All right, so. All right, so I proved it. I'm so confused. How do I merge it? So this is probably how I merge it, but I don't know how to give myself. Do I not have right access? I'm so confused. Why don't I have right access? How do I give myself right access? Settings, repositories, automate your network, settings, tell me how to grant myself right access. I'm really surprised that I don't have it, because right access, right access, right access, right access, right access. What I mean is the access to write to the repository. That's what I mean, is I want, as if a paper and pencil, to write to the repository, but digitally. I want the permissions to be able to do that. Tell me why I don't have the permissions to do that right now, because it's very strange that I don't, because I created the repository. So tell me how I can change it so that I do have the permissions to make a write, as if a paper and pencil, a write to the repository, so that I can approve the merge request.
Sounds like you're experiencing an issue where you're unable to merge a pull request in a repository you believe you created on GitHub. If you created the repository, you should inherently have all the necessary permissions to manage pull requests, including merging them.
Oh, you know what? I didn't create it. I forked it. So that's probably why, because I forked it. You know what? I did not create it. I forked it. Does this make a big difference, the fact that I forked it? Is that why I can't make my own merges? Will the merges that I make after it's been forked, the merges that I make after I... So after I fork it and I make merges, will the merges that I make affect the original repository that I forked, or will they just be local to my own forked repository?
When you fork a repository on GitHub,
Yeah,
you
that's
create
what
your
I
own
thought.
independent copy of the original repository. Here's how merging works in this context. Changes in your fork, any merges or other changes that you make in your fork will not automatically affect the original repository. They remain confined to your own fork.
Exactly.
Pull requests. If you want to propose that your changes be included in the original repository, you can open a pull request. This is essentially a request to the maintainers of the original repository to merge your changes into the original repository. Merging in your fork, you have full control over your own fork. You can merge pull requests, create branches, delete branches, and so forth without any limitations. Merging into the original repository, the maintainers of the original repository have control over which pull requests get merged into the original repository. Even if you open a pull request, you would not be able to merge it yourself unless the maintainers of the original repository have given you the necessary permissions.
Maybe that's it. Maybe because I'm requesting to yeah, see. So here it is. This is good. We're learning something. What we're trying to do is to merge 11 commits into this repository, which is what it was forked from. So that's not okay. That's not what we want to do. We want to merge it into this repository here. So let's cancel this. So we're gonna say whoops, accidentally attempting to merge pull request into the repo this was forked from. Okay, and then and now we can do close. So yeah, so if we go back to our pull requests here, we don't have any open ones, but we should have some closed ones. We can click on that. So we can see that for each of these closed ones, we were attempting to merge it into the original repository, which a good thing I didn't figure out how to change my permissions on that, because we would have ruined John Capobianco's wonderful work that he did. We would have gotten tomato sauce and gravy stains on the Mona Lisa. So, all right. So, let's see here. We've got. Okay. So now let's try making another one. But we'll hopefully have it. We'll hopefully get it right this time. Okay, so I go back to same link. So now we need to change this. We don't want it to go into the one that we forked it from. It looks like we have a number of other base repositories, people who have got the same idea I've got. I don't know if they're doing it on YouTube or just for their own thing, but this is the one we want here. Okay, so now these can be merged. So we'll say yeah, so there we go. We still got the same number of commits as far as I know. So say merging into the correct repo. And now we can create the pull request. You can also create a draft pull request, which is kind of nice sometimes. Then you know, you've got the files populating. You can see like the diffs in a really nice clear way. And then once you're ready, you know, it's already there, ready to go. So the draft is a good feature. And now we can see that the branch has no conflicts with the base branch, and I can merge the pull request. So I'm going to do that. I will confirm the merge. And there we go. Now I got it right. The pull request successfully merged and is closed. And now this branch can be deleted. So let's do that. So let's do get pull. And it's nice to delete. Yeah, so we'll do a delete branch. It's nice to delete your old branches, just so they're not going. You know, because if you do like a get branch and you never delete your branches, it's just gonna mess that up. Okay, so now we can do a get pull and we do a get branch. Now the thing is, this is my local branch. So let's say here, let's go to. Okay, so using get hub, I deleted the branch after completing a merge of a PR. Why is it still present here?
Deleted the grams_book_read through branch on GitHub. It only deleted the remote version of that branch.
Yes, exactly.
The branch still exists in your local Git repository.
Right.
Git maintains a distinction between your local repository and the remote repository, in this case, one on GitHub, allowing you to work globally before you decide to push any changes to the remote repository. To delete the local branch, you will need to use the git branch command.
Well, I mean, can I just sync it? What if I do is it like a sync or something? Fetch? Try that. Oh, sorry, git branch. Is there a way to just sync the local and remote together so that whatever is in the remote overwrites whatever I have local, so that I don't have to always remember to enter that branch -d command to make sure that they match?
Yes, you can synchronize your local repository to mirror the remote repository, but it is generally done in a few separate steps to avoid any accidental data loss. Git doesn't have a built-in command to completely sync global and remote repositories in one step, but you can use a series of Git commands to achieve this. Here are the steps to synchronize your local repository with the remote repository. Fetch all remote branches and tags. Use the git fetch command to retrieve all the data from the remote repository.
Alright, let's
This
try
won't
that.
automatically update your local branches, but it will retrieve updates and new branches, as well as deleted ones.
Okay.
sh copy code git fetch. I'll reset your local main branch to match the remote main branch. Reset your local main branch to match the state of the remote main branch using the git reset command. This command will reset your local main branch to be identical to the remote main branch, discarding any local changes, so ensure you really want to discard local changes before using this. sh copy code git reset card origin main delete local branches that have been deleted on the remote to delete local branches that no longer exist on the remote. You can use a git cleanup command that will remove any local branches that don't have a counterpart on the remote. Be careful with this command, as it will delete local branches. sh copy code git fetch pn and git branch vv awk. Done. Print $1 xargs git branch g check out the other branches and reset them similarly. If you have other branches that you want to reset to match the remote branches, you'll have to check out to each one and reset it similarly to how you reset the main branch. Pull latest changes to make sure all your branches are up to date with the remote. Check out to each branch and pull the latest changes. sh copy code git pull important note. These commands can result in loss of local changes, so always ensure you want to discard local changes before using them. It's often a good practice to regularly push your local changes to the remote to avoid any data loss. Yes, you can synchronize your local repository to mirror the remote repository, but it is generally done in a few separate steps to avoid any accidental data loss.
Okay, so that's interesting. But I've got it there. If we look at the branches down here, we can see I actually still do have this one. If I hit refresh, still do have it, which is like pretty interesting. What if I do a git branch? Okay, still have it. That's interesting. Let me try deleting that branch. Oh, let me do this. Git remote -v. Okay, so this is good. I was worried that it was the same issue where it was trying to interact with the pre-forked branch. Or sorry, the pre-forked repository. Let's delete this branch. Okay, so we deleted the branch. If we do get status, everything's good. Get branch. We're in the main, and we've got everything looking good. We've got the README updated, I presume. Yep, the README is updated. So everything looks good to go. Let's create another branch. So we're going to do git checkout. I'm going to say grams workload. Oh, you know what? Let's always try to use the built-in tools, because like I feel like that's where I can get like really powerful with this. So let's go to source control. So now we can see everything matches good. And let's click the create branch on here, and then we're gonna call it grams workload. We'll call it grams 914. Or like we'll call it like sprint 1 workload. All right, so we're going to create the new branch, and then we're going to switch to it. And there we go. We see that highlighted in green there. Now, we don't have it pushed up, so let's do that. Let's publish the branch. There we go. Let's go to the repository. And there we go. Now we've got that one there. Now, I thought this branch was deleted. Let's delete this branch. There we go. Okay, so now we should have, yep, so now we've got the branch here. we've got everything in there. Everything looks good. Okay, so that's kind of, hopefully that gives a sense of like, you know, how you use this on the job. You create all your changes in your own branch. Then you put your branch up as a pull request. People review it, and then they approve it, make comments, you know, what have you, and then you merge it into the to the main locked down code that it is live and ready to go. So this is a good example of that modern network development lifecycle. So now here's where I can sync my fork, and I can, you know, if he makes updates, I can bring those in. I can open a pull request to him and contribute here. Yeah, it's meant for collaboration, and it does it very well. So, okay, that looks pretty good to me. So yeah, let's go back to the DevOps here. We'll go to repos. There we go. Now we've got a repo here. So that's to set up the build. Let's see what this does. Okay, so this is for like pipelines. We don't want that. So it looks like we can create some, yeah, we can create some files and folders here. So let's do that. So this is how we're going to follow along with the book. Okay, so chapter 5. There we go. Now we're going to, we're not going to clone it and do it that way. We're going to do it using this here. So let's create the base folder structure. So we've got a README already. Now we need so we need hosts ini. Yeah, so here's what it'll look like. So let's create the hosts ini first. So hosts.ini, create, looks good. Okay, and then we'll create another, we'll create a folder, configuration, and then we'll create a git ignore in there. There we go. Oh, there you go. That's good. And we're doing this all in the main branch. So yeah, that's okay. All right, so we created the ini, and now let's create the first folder, which will be the configuration folder. Okay, so and then we'll create git ignore within it. All right, and then we'll do a commit on that. All right, and then we'll create another folder. I'll collapse this to make sure I don't accidentally create it in there. And this is documentation. And then a .git ignore. Create and commit. All right, so got a few more folders to go here. Next one is filter plugins. All right, commit that. And then we've got group vars. And then host vars. Oops, messed up here. Can't forget to commit, otherwise we'll lose all the changes. All right, so the next one is host vars. Looks good to me. Okay, and then playbooks. Oops, keep forgetting that commit. That's really important to not forget that. All right, playbooks. And we'll remember to hit the commit this time. So host vars playbooks. Next is tasks. And then templates. Oh, and I keep forgetting that. I'm really bad at remembering to do that. Templates. All right, so we've got everything to go here. So commit these changes with a meaningful message, such as initial folder structure, and then perform the first pull request and merge the folder structure and the completed INI host file into the master branch, and then delete the working branch. So I'm not sure if I'm in a working branch or not. So I did this all in the main already. That was not so good. I should have done it in a working branch. I don't know where he said to do that though. Yeah, so it looks like that's something that could be improved in the book, is to show this happening beforehand. It's kind of too late. So next is to test any organizational processes, change controls, approvals that have been put in place for network automation. Share the link and encourage others to clone the repository. So that's what you would do on the job, but we're just doing this in the lab. So I think we're good actually. So if I go to, yeah, so this looks good, and I'll demonstrate this kind of the power of this. If I click on clone, then you know, we can just grab that and put it on the machine where it belongs, which is connected to our network here. All right, so open Visual Studio on the network machine. Let me see what I'm at. Oh, hour mark already. Time's kind of flying by. I'm actually kind of enjoying this. All right, so I've got a few instances open, it looks like. I'll close this instance and open this one. Okay, so this is the automate your network from the other you know, this is from the forked repo, so we don't want to have it be that one. So it's kind of, I think that's why I changed the project name, because I'm almost tempted to go back and just do it again, because I should call it like Graham's automated network. Like that would be a good name for it. I'm kind of tempted to go back through all of that. And you know what? If I do that, then I can do this in a different branch and have it be nice and clean. I think I actually am gonna do that, and you know, it would help to to go through and to do it right. So here's the repository. Let's delete this repository. Okay. Oh. Let's go to this project and delete this project. There we go. All right, and then hopefully there we go. Now we don't have a project. There we go. I kind of want it to be like Graham's automated network, because I just want this to be the kind of thing where, like, if I'm on the job or like whatever I'm doing, I can just pull this down and be like, hey, this is my automated network, and it's just like, that's what it's called. So yeah, let's do it that way. So we're gonna call it Graham's automated network. We're gonna say implementation of the modern network development life cycle. C. And then can also have a link to the yeah, so we can have it. Yeah, okay. Pre-fork, post-fork, we can have that. All right, that looks good to me. So implementation of the modern networks. Let's see this, that, and that, and then I would like to have. Okay, yeah, this is already. All right, looks good to me. So yeah, we'll just keep this. No, I can't. It can't be public. Oh, work item process. I don't know. Oh, here we go. Oh, is this TFS? No, it's not. It's not. Yeah, this looks good to me. Okay. Oh, here's a kind of a breakdown of that. So, so basic. So choose basic when your team wants the simplest model that uses issues, tasks, and ethics to track work. So that's definitely what I want. I want to keep this as simple as possible. And then agile, that's kind of more what you'd want to use on the job. So use agile when your team uses agile planning methods, including Scrum, and tracks development and test activities separately. This process works great if you want to track user stories and bugs on the Kanban board. There's also Scrum, CMMI. So oh, this is great. So for workflow states, all you get is to do, doing, done. Here you get more product planning. So yeah, we don't even get user stories with basic. We just get issues, portfolio, backlogs, epics. You also get features here. So it's just how extensive. So I'm really happy with basic. Now let's create a repo. So let's start with the boards. There we go. So yeah, now let's create a new work item here. And let's follow along with the book. We'll just do this whole section again. So we're going to create a new work item. And let's just create a task. So it's going to be initial repo config, save, and then we're going to move it to doing. Okay, and now instead of cloning, so we don't even have, yeah, so we don't even have a repo to clone, so it works quite a bit different. So let's create the repo now. Oh, you know what? We do have the repo right here. But let's do it the same way, where we're yeah. So let's initialize the yeah, without a git ignore, we'll initialize the main branch. But now we'll do something a bit different than we did before. We'll create a new branch. Okay, so if we click down here on branches, we can click new branch here. There we go. And then we can call it initial folder structure. Okay, and we can't have a space there, so we're gonna call it folder structure. There we go, and we'll link this work item to it based on the main branch create. All right, so now we can work in this branch. Click on it. All right, so hopefully we can see some indication. Yep, so here's the indication of the branch we're on. We can switch over to the main like that. Switch back over to this. And now we can go through these steps once again. So we've got the README. We've got everything ready to go. So let's get all the files out of the way first. So this is going to be hosts.ini. Create. Okay, and I'm actually kind of surprised that you can't just you do have to oh, okay, yeah, this is where it was. So you do have to commit after each one, which I'm kind of surprised. I didn't think you'd have to. But hey, that makes it a little better, because now you have to put everything in, you know. Okay, so then we link the ticket to it. So okay, now we can create our folders. Okay. This feels a bit too much like actual work for me. But that's good, because like people who haven't seen this, you know, you've got a career, yeah, and you're not used to you've never seen the modern network development lifecycle before. I have. That's why this feels like work to me. This is good to see, because you can get some sense of this before having to deal with it in the wild. But yeah, it feels like I'm just working right now. Okay, group vars. Okay, next is host vars. Oops, and I'm bad at that. Okay, then playbooks. Tasks. And templates, and then that's it. Alright, so give that a quick review. Templates, tasks, playbooks, host vars, group vars, filter plugins, documentation and configuration. And we've got host.ini and readme.md. So we committed each of the changes. We didn't really use a meaningful commit name, but that's okay. Now let's perform the first pull request and merge the folder structure and completed host.ini file into the master branch. And then we'll delete the working branch. So let's hit create pull request. And then we're going to call it merge the folder structure. Okay, so we'll call it merge. We'll call it this. I think it can be kind of wordy. We'll see how many characters are allowed. I'll just say merge the folder structure and oh, do I have to complete the file? .ini into the master branch. Okay, so there we go. Describe the code, basic, modern network development. Let's see, folder structure. Okay, so yep, that looks good. You can add reviewers, whatever you want. Hit create. And then we can hit complete. There aren't any merge conflicts. So I'll hit approve. Approved by me. Complete. Now this is where the merge type is kind of interesting. I wish I could. Okay, so it's merge, squash, rebase, and fast forward, or semi-linear merge. Of these options, merge, squash, commit, rebase, and fast forward, and semi-linear merge, which are the best merge types to have for my pull request?
Best merge strategy for your pull request depends on your team's workflow, the complexity of your project, and your preferences regarding the cleanliness of your repository's history. Below, I will explain each strategy and in what context it might be best used. Merge commit, merge pros. Preserves the complete history and individual commits. Allows for detailed tracking of changes and collaboration. Cons. Can result in cluttered, nonlinear history with many merge commits. Best use. When you want to maintain detailed histories of future branches. When individual commits are substantial and provide meaningful history. Squash and merge pros. Creates a clean, linear history by combining all future branch commits into a single commit upon merging. Simplifies history, making it easier to track changes over time. Cons. Loses detailed commit history of the feature branch. Best use. When individual commits on the feature branch are not substantial or meaningful in isolation. When you want to avoid cluttering your history with many small, incremental commits. Rebase and merge pros. Maintains a linear history by replaying feature branch commits onto the main branch. Keeps individual commits, preserving the granularity of the history. Cons. Can result in complex conflicts during the rebase process, especially for long-lived branches. Rewriting history can be confusing and error-prone. Best use. When you prefer
Not
linear
this
history
one.
but want to maintain individual commits. When collaborating with a small team to minimize conflicts. Fast forward pros. Maintains a linear history without creating a merge commit, as long as the feature branch is ahead of the main branch. Keeps the history clean and straightforward. Cons. Not always possible, especially if there have been other changes to the main branch since the feature branch was created. Best use.
Not this
For
one
small
either.
changes or hotfixes that don't require a detailed history. When you're working alone or with a small team. Semi-linear merge pros. Combines the benefits of rebasing and merging, creating a linear history of individual commits without a merge commit. Cons. Like rebasing, it can involve complex conflict resolution. Best use. When you want.
Okay, so I want either this one, or this one. So individual commits on the feature branch. So basically, what you're doing is you're saying, do you want every commit that you made? So like, do you want all of this to be added to your main branch, or do you want this to all just be condensed into one commit message? Then you click from there and you see that. I want it to be condensed. So I think I want to do squash commit. So because then we get a clean linear history. All my branch commits are just one single commit, so it's like it makes it easier, and you can probably click on that branch or I don't know. Well, I'm going to be deleting that branch. I mean, you lose the detailed commit history of the feature branch, which is kind of sucks. Man, help me decide between merge commit and squash and merge. I am reading through a book called Automate Your Network, and I am practicing the modern network development lifecycle, where I will have all of my network configurations up in a repo, and I will be making changes to the repo. This is just a project that I am doing myself, but I want this project to be usable in the real world. Basically, I want to set myself up for success with that project and make the tough decisions in ahead of time, or at least understand what those tough decisions are. So if that is the case, what is better for me to use?
Absolutely, deciding. On a merge strategy is indeed a crucial decision in setting up your version control workflow. In your case, where you are working alone on a project to manage network configurations, we can weigh the pros and cons of both merge commit and squash and merge to find the best fit for you. Here we go. Merge commit pros detailed history. You will have a detailed history of all the changes made in each commit. This can be beneficial when you want to understand the development process in detail or revert to a specific change in the branch history. Individual contributions. Since you are reading through a book and implementing changes step by step, individual commits can represent your progress chapter by chapter or section by section. Cons complex history. Over time, your commit history can become quite complex, making it harder to navigate and find specific changes. Squash and merge pros clean history. This strategy will result in cleaner, more readable history. Each feature or set of changes will be represented as a single commit, giving you a high-level view of the changes made over time. Avoids clutter. If while learning, you make a lot of trial and error commits or tiny changes, squashing will help avoid cluttering your history with these non-significant commits. Cons loss of detail. You lose the detailed history of your development process for each
That
feature or set
sucks.
changes. If a problem arises, it might be a bit more challenging to pinpoint the exact change that caused it. Recommendation for your project, considering you are setting up a repository for
that's
network
what I
configurations
was
and working
thinking.
alone on a learning project, squash and merge might be the better option for the following reasons.
Yeah.
Learning curve. As you are learning and implementing changes step by step, there might be a series of small, iterative commits that, while important in the learning process, might not be very meaningful in the larger scope of the project history. Clean history for future reference. Once you start using this in a real-world scenario,
Right.
having a clean history will make it easier for you, and others if it becomes a collaborative project, to understand the significant changes and milestones in the project.
Yes.
Focus on current configuration. In network configurations, the current state of the configuration is often more important than the detailed history of how it got to that point.
Right.
Squash and merge allow you to focus on the current configuration by presenting a high-level view of the changes. However, during the learning phase, you might opt to use merge commit to preserve the detailed history as a learning tool, and then switch to squash and merge once you are more confident in making more substantial, meaningful changes.
No, I'm confident.
It's a flexible choice, and Git allows you to change your strategy as your project and skills evolve.
Okay, so I mean, confirmation bias, but it okay. So yeah, let's go with squash commit. We don't need to. Yeah, you know what? Let's customize it. And then we'll give it what we got in the book. So. Oh, you know what? This is fine. It doesn't need to be customized. Yep, and then we'll delete the branch it was working with, and we'll complete associated work items after merging. Yeah, there we go. So perfect. So we don't even have to move this to complete. It'll be done automatically. So I'll click on that, and now these weren't squashed. It looks like. Oh, it was for here. Let's go to the branches. Okay, and then we'll click on this here. Pull requests. Confused. Oh, history. Okay, so now we can see. I think this is probably proof in the pudding that it's been squashed. Otherwise, we would see each of the commits in the history of the branch. So I don't know why anyone would want them all to show up like that. That seems like a nightmare. Especially since you can just click on it and see them there. So maybe I'm not understanding what that actually does, but in any case, this seemed to be the right option for me. This looks really good. Okay, so let's move on. Well, first let's check our Kanban board. So we're gonna go to boards. Oh, and it looks like our task just completely was deleted. So that's kind of not so good. Interesting. So here's a work item that was created, but I don't see where it is. Backlogs. Where's the Oh, because it's by issues? No, it should be by issues. Oh, it should be by tasks. So these are recently updated. I don't know what happened to my work item. I can see that there's a work item here, but I can't look at it anymore. Maybe it's an artifact? No. What happened to my work item? Maybe recently completed? Oh, there we go. So yeah, if we go to recently completed, now we can see the work item. It wasn't assigned to anyone. I'll assign to myself. That might make it. Yeah, I think that'll make it easier to track. So if we go to work item and we go to assign to me. Okay, it looks like all we're seeing is the looks like we are filtering things out. But we can go to completed and we can see the recently completed ones. Alright, so I guess I'm happy with that. Okay, so moving on. Uh, you know what? I think I'm at the hour mark now, so this was a success. So I think I want to finish it here. I'm pretty happy with how things went. Um, so I think I want to do this next step. You know what? Let's just do the configuration down to documentation and then end it there. So the configuration folder should have subfolders by platform or operating system to scale, and should hold more than just one type of configuration file. The configuration folder holds dynamically generated output that is the result of the documentation.yaml playbook that will be written later in this book. Think of those files as intent-driven sources of truth and the result of the data models and templates being compiled. Using a folder to hold these files means having an offline version of the configurations that can be referenced. It also means having automated documentation that is updated after every change. It is another way to validate the command's syntax before pushing commands to a device. Okay, so we don't have to do anything here. This is just what it will look like after we run the playbook. Okay, so this is just, all of these are just showing us what it'll look like after we run the playbook. So I guess I want to get, I want to end this at the end of chapter 5, and then I want to start my next video at the beginning of chapter 6. So let's read each section. So we finished the configuration session. We'll start with the documentation section, get all the way through, and then close out this video. I'm going to pause it and be right back, but I don't want to stop this video until I finish chapter 5. All right, I'm back. Let's close this out. I am having chest pain, but I will ignore that. I think it's just heartburn. All right, so documentation. This is another folder that contains all dynamic configuration documentation files. These can be markdown.md files, Excel files .csv, text files .txt, or other documentation generated by the playbooks. It is important to remember that since all these files are part of the repository, they have the same version controls, Git and TFS history, and other metadata as the other files in the repository. This history can be used to view human-readable output in a Markdown or Excel format instead of trying to read the configuration-centric view in the dynamic configuration files in the previous folder. And this was where it's like trying to read the configuration-centric view. It's like, that's, you're going to tell like a CCIE that you're just going to try to read a configuration and you're going to fail at it. It's like, reading configurations is what we do. But anyways, okay. So here's an example of the documentation. So there we go. MD, I'm not sure what that stands for. Oh, Markdown. So these are the Markdown documentation. We've got Excel documentation, technical playbooks, reconnaissance playbooks. Then we got it for, yeah, so this is for iOS operating system. This is for Nexus. All right, so the next one is filter plugins. The filter plugins folder is part of the Ansible framework and is a place to store Ansible plugins. Ansible plugins include Python files that enhance the default capabilities and augment Ansible's core functionality. Write custom plugins in Python and store them here. A complete guide to Ansible plugins is available here. So this might be, I think I'm going to look at this. So this is for Ansible version 2.7. We can kind of get a sense of the datiness of the book. So I don't see like where to select or like what the newest version is. but this is probably a good thing to save. I'm going to save this in my notes. So let's do that. So we're going to go here. We're going to open this, say readme, or it's not readme. We're going to do book read through notes. There we go. And then we'll say Ansible plugins. Oops, wrong thing. All right, there we go. Ansible plugins. So that looks good to me. So yeah, let's commit that change, push it. So we're gonna stage the changes here. Now, which branch are we on? Oh, usually these are highlighted in green. I don't see it highlighted in green. Okay, but I am on this one. Yeah, I'm surprised that's not highlighted in green. That's kind of annoying. But adding link to Ansible plugins help. That'll be useful. All right, so we're gonna sync the changes, and then these are just in my branch for now. Just kind of want to get those good habits going. So writing everything just directly to your main branch is not necessarily a good habit. Okay, so there we go. The next folder that we created was group vars. The group vars folder contains the data models applied to groups of devices in the hosts.ini file. This folder contains YAML files created to contain data models. Group vars folder matching the sample hosts.ini file are as follows. There you go. So they're all YAML files. I'm not sure what this is. This looks like a typo or something. Okay, so the next one is host vars. The host vars, similar to the group vars folder, contains the data models that apply to each individual service, each individual device or host in the hosts.ini file. This folder again contains YAML files, but in addition, a file per device using the device's hostname is created. Host_vars folder matching the sample host.ini file is as follows. So we've got the layers of the network, each of the devices. The next one is playbooks. Playbooks is another folder required in the Ansible framework. This is where YAML files that make up Ansible playbooks are stored. It is a good idea to have some structure either by platform or function, as well as another level of folders for network reconnaissance playbooks, tactical playbooks, and network management playbooks. Think of these as executables. Use Ansible-playbook commands to run these playbooks. Okay, so here's all the playbooks. It looks like so the playbook itself is the YAML. So this is just a folder hierarchy. Tactical recon management. We've got that for each of our 3 networks. So we've got the campus network. Let's take a look at that in the lab. All right, so here's our campus network here. So they're using like OSPF links. We'll use that. Then the data center here. Then the WAN that connects the data center and the campus. It looks like they have a port channel. And then they have an extra network here called the DMZ network, demilitarized zone. I'm not sure what this is. I don't have that yet. I guess this here would be like the DMZ. But we'll focus on that when we get there. So the next folder is the tasks folder. Tasks is another folder required in the Ansible framework. The tasks folder holds all the YAML task files that call Ansible modules. A similar folder structure to the other folders should be created for scalability and to keep tasks sorted by environment and function. The tasks in the configurations subfolders match one-to-one with each of the Jinja2 template files created. This is not meant to exhaustively cover all the files created, but rather to give a picture of the folder structure and samples of the tasks of the types of tasks required and where to store them. Okay, so we got ad hoc tasks, so like copy run start, copy run up to the database. We've got auditing, we've got configuration tasks. So the full list of templates is available in the Git repository. So let's take a look at it. Or the full list of task templates, I guess. So yeah, ad hoc, audit, configurations. I'm not sure what big IP is. I actually don't even see it. Yeah, I don't even see big IP. It looks like it's another kind of networking vendor. All right, so the next one, and I think the final one, hopefully. Yeah, the final folder, then we have a file to look over, is the templates folder. It's a part of the Ansible framework and is where Jinja2 dynamic template files are kept. Like all other folders, templates should be structured to scale and organized logically. In the example, there are 3 top-level folders: banner, configurations, and documentation. These folders will have subfolders by platform, such as iOS or NXOS. The banner folder is a simple text file that contains the standard banner displayed on all devices when a user logs into the CLI. The configurations folder contains all the dynamic templates used to generate device configurations. The documentation folder contains the templates used to generate the markdown automated documentation. These templates have a matching YAML file in the task folder that includes the module used to compile the commands. All right, so here's the templates. We got it for banner, configurations, documentations. We've got it for all of our different types of gear. All right, so the next one, and this is the final one, thank goodness. It's the host.ini file. So the Ansible host.ini file needs to be stored in the root of the repository. So here's a sample host.ini file. So we do have this DMZ zone. I don't have that. Let's kind of compare this to the network. So we've got the enterprise. So this is our whole enterprise. Our whole enterprise has the WAN connecting the data center to the campus. So we have all those. We have the campus here. We have the data center there. We have the RAN there. We also do have a DMZ, demilitarized zone, and I'm not sure what that is. It's probably like this here. So in the campus, we have 3 layers. We have the core, the distribution, and the access layer. Okay, we got that. That looks good. Then in the campus core, we have this device here called core. In the campus distribution, we have these 2 devices here. One is called dist1 and one is called dist2. And then in the campus access, we have 3 devices. It looks like they're split up in kind of a strange way. We've got the 30. So we have the 2 kinds of devices here. We have a 3850 and a 3750. That's the same in my lab too. One of these devices is different. If we do a configure, hopefully we can see that somehow. Oh yeah, so we can see that here. So it's a L2. Yeah, so it's one of these is this, and I guess you'll just have to take my word for it. No, so you can see there's a EXOS, so it's different. Okay, so there we go. And then we've got the for the 3850s, so that's these two here. We have Axis 01 and Axis 02. The 3850s in my case are these VIOS images. Then for the Axis 03, that's the unique device. So I have a EXOS, and I can start up this lab. It doesn't matter. Okay, and we can look at each of these devices just to see what the CLI looks like. So this core device is just a tried and true Cisco device. Pretty simple, straightforward. We can do like a show interface on them and stuff. I architected this lab with the help of the AI, so I don't know, things might be a little bit wonky, but we can take a look. So if we take a look at the show run on here, really nothing on there yet. If we do a show interfaces description, there we go. We've got these 3 gig interfaces on there. Yep, so pretty standard stuff if you're familiar with Cisco. Now here's where it gets kind of funky. We've got these distribution switches that I don't think are Cisco switches, and then we've got the access switches that are funky as well. And we can see the difference between them already. For this access layer switch, you know, we have a lot of we have a lot of ports. You know, so that's kind of the reasoning for that to be at the access layer. So here's an Arista here. Now this is a oh, I don't know what the password is. Admin with no password. Okay, so here's oh, yeah, so it gets pretty no, I don't want to disable it. Would you like to read more? No. Disable telnet? No. No, we don't need SNMP yet. Definitely not. No, let's not. Okay, there we go. So it wants me to change my password. Now I have used Extremes quite a bit. It's just been a while. I think we can do. I think it's still most of them has like show. Most of them it's really not. Yeah. So if we like show interface, or like show port, I think. Yeah, show ports. And then we could probably even do like a description. There we go. So now we can see all the ports on the Extreme. This is another one that has quite a few ports on it. It's got 12 ports. So this is the access layer switch. We saw the access layer switches have all kinds of ports because, you know, you put this on the floor of the office. You put this on in between the floors of the office. So in an office building, you know, you've got a floor with 40 people on it. They all have to connect into the access switch. So you need a lot of ports at the access layer. Distribution layer, you don't need as many, and then you need even fewer at the core layer. But what you need is you need a lot of really high bandwidth ports. So these are all gig ports, gig 0 through 3, and then the distribution. We've got Ethernet ports. I'm not sure whether they're gig or not, but you need that distribution as well. But at the access layer, you can have just some, you know, Ethernet ports, 100 mega. I mean, 100 megabits is like kind of slow nowadays, but it's not that bad. Like if you do a speed test, yeah, I'm at 80 right now, so like 100 is good, but like if you're in like a office building and especially with like a bunch of software engineers and they need a lot of bandwidth. Like, hopefully you can do right by them. Okay, so here's the oh, we're gonna, yeah, we'll do admin, we'll do zero touch cancel. Oh, I didn't want to do that. Anyway, you'll just have, this is an Arista, you'll just have to take my word for it that it's that it makes sense to have on the network. Yeah, so that's the campus. We're done talking about that. The next one we got is the data center. So the data center has these devices here. These are the 7Ks, I believe. Oh, we've got a we're at the bootloader shell. Oh, so we've got to give it an image to boot up to. Let's try going on this other one. Okay, so yeah, that's the same thing. So let's do boot and then checksum failed. Okay, so shoot. Okay, here we go. So this is for setting the network configuration. And see how I do this. Like this, you know, I've got, you know, my fair share of experience. I'm not a noob here. So like, see how I've never been on this device before and I'm figuring out how to get help on it. Like that's a really important skill. You got to learn how to use the help menu. Okay, so I tried feeding it a device file. Let's try it from boot flash. That didn't work. Oh. Okay. I don't know what's going on there. So that's the data center. Okay. So I can't boot this one up. There's some kind of issue there that I'll need to figure out at some point. I mean, it should be good to go, right? Maybe the disk interface has to change. T-Flash. Virtual IO. Let's try that. Now it's just not doing anything. This one doesn't even have a disk image. I guess I'll change this one back to SATA. Alright, and then try rebooting it. Maybe I can get back to that bootloader menu. Oh, you know what? It worked. Oh, that worked actually. Okay, so I think we even get Python on these. Oh, no. How do I get the shell? Systems help for Go drivers. This. I mean, I can always do the I can do a ver. Yeah, and say like what is happening here. So this is a networking device. What is happening here? How do I get to where I can configure interfaces? So that's it there. This is a networking device. What is happening here? How can I get it so that I can configure interfaces? Yeah.
What you're seeing here is the UEFI, Unified Extensible Firmware Interface, shell, which is a pre-boot environment where you can manage firmware and hardware settings, run scripts, and perform other system management tasks, including network configuration. From the UEFI shell, you can manually configure hardware settings, including networking settings, though it's typically not the place where you do most of your network configurations.
Yeah.
Normally, you would boot into an operating system to configure network settings using the operating system tools. However, if you do want to manage network configurations from the UEFI shell, here's a general idea of how you could go about it. Get a list of network interfaces. Use ifconfig command to get a list of all available network interfaces. This will show you all of the network interfaces that are available in their current configurations. Shell copy code shell greater than ifconfig configure network interface. Use the ifconfig command again to configure an interface. You can specify the IP address, subnet mask, etc. that you want to use. PHP copy code shell greater than ifconfig less than interface underscore name greater than less than IP underscore address greater than less than subnet underscore mask greater than replace less than interface underscore name greater than less than IP underscore address greater than and less than subnet underscore mask greater than with the appropriate values for your network. Ping test. Once you have configured your network interface, you can use the ping command to test network connectivity. PHP copy code shell greater than ping less than IP underscore address greater than replace less than IP underscore address greater than with the IP address of another device on your network to test connectivity. Manage boot options. If you are trying to boot over the network, you may need to manage your boot options with the BCFG command. You can use this command to create, delete, and manage UEFI boot options, including network boot options. Load network driver. If the network interfaces are not showing up, you might need to load the necessary driver using the load command. You'll need to know the path of the driver file to use this command. Lua copy code shell greater than load less than driver underscore path greater than replace less than driver underscore path greater than with the path of the driver file. Reconnect devices if necessary. You can reconnect drivers to the devices using the reconnect command. This might be necessary if you have loaded a new driver and need to connect it to the hardware. Shell copy code shell greater than reconnect R after setting up your network interface. Save any necessary changes and exit the UEFI shell to boot into your operating system, where you can continue to configure your network settings using the OS's tools. Keep in mind that the changes made in the UEFI shell are low-level changes, and you should proceed with caution to avoid misconfigurations or other issues. It is highly recommended to consult the specific hardware manual or support resources for detailed guidance on configuring network interfaces in the UEFI environment for your specific hardware.
Okay, so this is UEFI. Remember that from my other series, the LPIC series. Such a great series because, you know, this is all, important stuff. So it looks like we're making some progress here. We just need to figure out. Let's go to the boot manager. And then let's try to boot up to. Let's try to get the actual. So let's do this. QEMU CD-ROM. Okay. And then I'll continue. So we don't want to skip that, so I'll just wait for 5 seconds. Yeah, so that didn't work. Device manager. RAM disk. Network device list. I'll reset because I made some changes. Yeah, so obviously there's some issue with boot. I'll deal with it later. Right now I just want to finish out the chapter 5. So we don't need to read everything. Well, you know what? Let's go ahead and review that everything matches. So we've got the data center. We've got the 7Ks here, DC1 and DC2. Then we've got the 5Ks for DC1 and DC2. I don't know what happened to DC. Oh, right. Oh, right. This is where the book was like really confusing about this. So their network doesn't really look the same as mine. So now we've got the WAN network, so WAN XS, and then you got a different one than mine. And then they've got some DMZ devices. So I guess I could name this DMZ01, DMZ02. I don't know. But that's the end of chapter 5. So thanks for watching and stay tuned for the next video when I start chapter 6.